Hello everyone, welcome to JSON Diaries with Ro. In my previous video, I showed how to create a new USGS Earth Explorer account and download Landsat imagery. The link of the video is given in the description box. In this video, I'll show how to pre-process Landsat imagery step by step. We'll cover radiometric calibration, atmospheric correction, and pan sharpening. I'll use ENVI 5.6 for pre-processing of Landsat imageries. This is the interface of ENVI. My Landsat bands and metadata are stored here. Now I'll open the Landsat bands, click File, Open As, Optical Sensors, Landsat, GeoTIFF with metadata, and select the folder where you have stored your Landsat images. Click the metadata file and select Open. But this shows an error. To open Landsat 8 images in ENVI, you need to perform a small change in your metadata file. Open your metadata file and type L1 instead of Landsat. Save your metadata file. Then we'll try to open our Landsat images again. This is our Landsat image. I will import my study area also. Pre-processing the entire Landsat tile requires too much time. To reduce the computational time, I'll clip the Landsat image according to my study area. And then I'll perform radiometric calibration, atmospheric correction, and pan sharpening to my clipped Landsat image. To clip the Landsat image, type Research in the toolbox. Select Resize Data. Select the multispectral bands. Look, here are 7 bands. This is the multispectral band, and we'll perform pre-processing to this multispectral band set. Click Spatial Subset. Then select ROI and select your study area. And then click OK and select your output file location. I'll type the name of my output file. Our Landsat imagery has been clipped according to our study area. I will also clip the panchromatic band to perform pan sharpening. Select the second one and look at the pixel size. It shows 15 meters. And we know panchromatic bands in Landsat 8 imagery have a pixel size of 15 meter. Click Spatial Subset and then ROI and select your study area and click OK and select your output file location. Our panchromatic band has been clipped according to study area. And now we'll perform radiometric calibration to our clipped Landsat imagery. Type Radiometric Calibration in Toolbox and select Radiometric Calibration. Select our clipped Landsat imagery and look, 7 bands are selected here. Click OK. I will apply flash atmospheric correction. So I'll select Apply Flash setting here. and then select your output file location. Click OK, and our radiometric calibration is done. You can see the difference between the radiometric calibrated image and the original Landsat image. Now, let's perform flash atmospheric correction. Type flash in toolbox and select flash atmospheric correction. Input your radiometric calibrated image here. I'll select my image. Select Use Single Scale Factor for all bands. Click OK. Select Output File Location. Type root name for flash file. I'll type flash. The location coordinates of my Landsat images are already showing here. If not, then type your location coordinate manually according to your study area. Select sensor type. I am using Landsat 8 OLI, so I'll select Landsat 8 OLI. The software has already entered sensor altitude and pixel size based on our sensor type. Enter your ground elevation of study area in kilometer. You can find your flight date and flight time in your metadata file. Open your metadata file. Scroll down. Here is our flight date. We'll enter our flight date. And this one is our flight time. Select atmospheric model based on your study area. I'll select tropical. Select aerosol model based on your study area. I'll select tropospheric. In aerosol retrieval, I'll select 2-band KT. Select multispectral settings. Select Kaufman aerosol retrieval. Change the defaults to overland retrieval standard 660 to 2100. You can select any of it based on your requirements. And I'll check the information again. You should select atmospheric model, aerosol retrieval, and other necessary information based on your study area and your requirements. And I'll select apply. Our atmospheric correction is processing. Our atmospheric correction is done. I'll open my atmospherically corrected image. I'll select True Color Composite, red, green, and blue bands. Select Load Data. You can clearly see the difference between radiometrically calibrated image and atmospherically corrected image. And also the difference between atmospherically corrected image and raw satellite image. Now I'll apply pan sharpening to the atmospherically corrected image. Type pan sharp in toolbox. I'll apply gram pan sharpening. You can choose any of it based on your requirements. Select the atmospherically corrected 30-meter pixel size image. Our 7 bands are selected here. Click OK. And here, select our clipped 15-meter panchromatic band. Click OK. Enter your sensor type. I'm using Landsat 8. And I'll use nearest neighbor as resampling method. And I'll enter output format as TIFF file. And select your output file location. Click OK. Our pan sharpening is done. Now I'll open the pan sharp image in Arcmap. I will connect the folder where I have saved my pan sharp image. And import my pan sharp image. I will apply True Color Composite for the pan sharp image. Select band 4 for red. Select band 3 for green. Select band 2 for blue. Now I'll check the properties and see the cell size or the pixel size is 15 meter by 15 meter. It has been reduced to 15 from 30 by pan sharpening. I'll import my study area. Now I'll clip the pan sharp image according to my study area. Open your search bar and type clip. Select the Clip Data Management tool. Select the pan sharp image as input raster. Select your study area as output extent. And check the box here. And click OK. This is our pan sharp image, and I'll apply True Color Composite again. Now you can see the features more visible and clear. You can export this image in your folder. Select Data and then Export Data. And select your file location. And type your file name. And click Save. I'll add the exported data. You can also click No. This is our final image for further classification. Thank you everyone for watching this tutorial. See you in next video.